Okay, so let's take a look at this part now. This one is going to be a decreasing sequence, meaning that A1 is going to be greater than A2, you know, oh, meaning A1 is going to be like a greater set than A2, meaning A2 is a subset of A1, and so on and so forth, right? In this case, we want to define as well the limit inferior, limit superior, but we want to see how this works. So again, we have our sets from left to right, and yeah, this is at the beginning. It continues on, as you can see, it decreases. So this guy includes everything, right? A1 includes everything. AN includes less than A1, and AN plus 2 includes less than A1, as you can see. So yeah. So in this case, we want to take the following understanding of it. So if we take, let's say, the intersection, right, of A of n at n equals 1, let's say here, right, n equals 1, then simply put, it's going to be the same as saying, yeah, we just have to follow this rule, you know? Why? I'm not sure why. Let me just look at it real quick, because I totally forgot about it, if I'm honest. It says here that the intersection of A of n. Oh, well, simply put, yeah, that makes sense. So the intersection of A of n beginning here, right? It's simply going to be this little guy here, right? As it goes to infinity. So we can just say it's going to be AK as k goes to n. So it's going to be the same thing. So we can equalize that. Now, what about the union? What, right? So we take, I don't know, an, right? And let's say that we begin with a union of ak equal to n. This is simply going to be an, because we're including this one with this one with this one with this one. It doesn't matter what we do, right? So yeah, so if we begin at 1, let's say we begin at infinity, k equals to 1, we would begin at the 1, and then union of the second one, and then union for the third one, fourth one, fifth one, doesn't matter. But at the end of the day, A1 already includes everything, so this is going to be basically just A1, right? Now in the same scenario, let's look how this would work with intersection. So in the intersection of k equal to 1 to infinity, right? And let's take a look at this. The intersection will be, okay, the intersection of this one, and then this one, and then this one, and this one, and this one. At the end, the intersection is going to be, simply put, this guy here, right? So it'll be the same as saying we start from the beginning, or we start from here, or we start from here. It doesn't matter where we start from. It'll always contain this little guy. So that's why we state this part. So after checking these two properties, which are the most important things that we have to see, we can now focus on finding the limits inferior and superior. So limits inferior states the following. As we know, this will be the intersection, and the intersection is going to be equal to this, right? So we can just replace it, and this is a union and an intersection. The union and intersection, it doesn't matter. So it's going to be a union of intersections. It'll be just the intersection because it has the same index. So it doesn't matter. We cancel this one out, basically, and we're going to have our end result. Now the same thing goes here. In this case, we have the union of AKs, which we know is going to be just AN. So it's going to be the intersection of AN. And simply put, that's it, right? There's nothing else to do here. And again, as we've already stated, we can copy this and we can paste it over here. And we have shown that these are all the same. In this case, we're going to change just this really quick thing. Oopsie. And we can conclude that this is it for a decreasing sequence. Right? And that's it. that's pretty much how you solve these two. And now we're going to go with an actual formal, well, concrete examples of sequences to see and find the limit superior and inferior. Okay, so we're back, and right now we're working again with sets. In this case, we're going to be working with just limits of sets. So in this case, we're given that limis infimum is declared as this, and limis supremum is declared as this, right? And they're asking us, okay, if we have an increasing sequence of sets, then we have to prove this, right? To prove this, it's simply put, we have to show that these two are the same, in fact. So we just have to see that these are the same, so to speak. If these are the same, then we can just conclude that the limit as an increases would be whatever these two are, right? So doesn't matter. So let's continue. Let's try this out. So in this case, we're given an increasing set sequence. This means, if we look at it, that a of n, a1, right, is smaller than a2, which means a1 is a subset of a2, and a2 is a subset of a3, a4, a5, up to an, right? And for an, well, an will also be a subset of an plus 1, and so on and so forth. So now we want to understand the following intuitions, which is, what does this mean, right? Let's take a look, because we are taking, basically, this guy, and we're placing it here, and we want to see what this is equal to. So this guy simply says, okay, let's take the union of whatever, right? Let's say k equals n, so let's take this one. The union of ak is going to be basically the union starting from here. Why? Because as you can see, this guy already includes this whole section, right? Oops. It already includes this whole section, all of this, right? It already includes all of it. Meaning that this will be the same as saying this, because it's an increasing set. Therefore, we can state these as these are equal. That's for the union. And now for the intersection is quite interesting. If we say, okay, let's start from kn, right? K equals n. And the intersection of all of these is simply going to be a of n. Let's take, for example, a1. Let's take that in this example. Let's write here, just to illustrate this, that k equals 1, right? So we begin at the intersection of this guy. As you can see, as we go forward and forward and forward, the only intersection that we will have is this here. So this is simply put, well, this is just a1, right? So if n is in this case, it means that it'll be an, right? So that's the intuition behind that logic. So we can, with these two, we can simply rewrite our limit superior and inferior. So in this case, we know that is denoted like this, right? And we know that whenever we have an intersection of ak starting with ak k equals to n to infinity, then the union, it's going to be basically just an. This thing is going to be an, as we already declared here. Therefore, this is just going to be the union of infinity n equals to 1. And we're done. That's a limit inferior. Now, the limit superior, in this case, we can say, okay, it's the limit intersection, n equals 1, boom, boom, the union, whatever, k equals 1, k equals n, sorry. This is simply going to be, right, the same as saying, okay, the union of ak at beginning at n to infinity is going to be the same as n equals to 1 an, because it's a subset as already stated here. If we take this and then we unionize this guy and this guy and this guy, it already includes all of these. So it's the same thing as saying we start from the beginning. Therefore, we can just write this in here. We just replace this one with this one. And at the end, because we have the same indexes and everything, just an intersection of the same union is going to be the same thing. So we're going to have, at the end, the union of A of n. And because we have declared that these two are the same, right? We can say that the limit of A of n as n approaches infinity is going to be equal to the union A of n for an increasing sequence. Oops. Meaning this, right? Right? That's it. So yeah, this is how you solve this one. And yeah, now we're gonna, next video, the next part is gonna be just for the opposite when it's decreasing. So yeah. Okay, so we have first this little guy. This little guy is quite easy. So we have, for example, we're gonna start with this, and we have A of n, right? Is going to be the sequence of -1 to the power of n. So we want to find the limits inferior and the limit superior, see if they're equal, and if they're equal, we give out the actual limit. So let's check it out. I wrote first, I first copied these two in here so we can analyze them. So let's check out the limits inferior first. The limits inferior states this. So we take the union, right? And then the intersection of all of these. Now let's take a look at how this works. So A1 is going to be just -1. Just 1, sorry. Because -1 to the power of 1 is going to be just -1. And A2, as it's an even number, is going to be 1. And A3 is going to be just -1. And it continues on and on and on, just alternating between -1 and 1. So the intersection between all of these, although they're alternating, it doesn't exist because there's no intersection. Therefore, we can say, surely, that the intersection of all of these is going to be the empty set. And the union of empty sets is just the empty set. Therefore, the limits inferior of A of n is just an empty set. There's nothing else to do here. Now, for the limit superior, we take a look at these as well. So we take the union of all of these. So we unionize A1 and A2, A3, A4, A5, A6, A whatever. And at the end, we have two elements that always are going to be there, -1 and 1. Therefore, we have -1 and 1. And the intersection, right, of infinity as, let me just think. The intersection as n goes to infinity is simply going to be the limits superior. So that's it. It's going to be -1 and 1, simply put. In this case, I'm not sure why it was -1. Well, let me just check. Right. The limit superior. Hold on. Oh, well, yeah, just an intersection of all the sets. Meaning we take all these sets and we want to, well, yeah, just the union, and then we take this guy, and there's no index, So the intersection of this is just going to be simply going to be this. There's nothing else to it. And we got a result. That's pretty much it. Okay, so the last one here, we have another sequence which just has an 1 to 1, is a range from 1, that includes 1, to 1 plus 1 over n open, meaning that as the sequence grows, we decrease our range, right? And as we decrease our range, we can see a pattern that says that a1 is going to be a bigger set than a2. So a2 is going to be a subset of a1, meaning that a5 is going to be a subset of a4, a4 subset of a3, a3 subset of a2, and so on and so forth, which works perfectly fine. Now, we want to see that this guy, as n goes to infinity, the limit is going to be 1 because this turns into 0. Therefore, we can simply say, hey, right, let's take a look and remember this, that this is a decreasing sequence. And for a decreasing sequence, as we already checked, the limit is going to be the intersection of a of n, right? So the intersection of a of n, simply put... You good?
What?
I'm just recording and just it can sound more like a fart than a laugh.
Look.
Jeez. Okay. So we have this intersection, right, of a of n, and as n goes to infinity, right, as you can see, it'll approach, basically, we can say that a of n, as n approaches infinity, it'll approach to the set of 1, 1, right? Therefore, we can take a look at these and say the intersection is going to include this only, right? So we can write this here, and as we know, that's only going to be 1. And again, the limit inferior is equal to that, bless you, and this is going to be equal to that, which is the same thing, meaning our limit does exist as these two are equal. Therefore, limit of a of n is only 1. In the other case earlier that we did, these are not the same, therefore there exists no limit. So yeah, there exists no limit. So that's how you solve these, and that's pretty much